Alright, we're starting chapter 5 here, section 5.1, operations with polynomials. We're going to start off nice and easy here. We're actually going to start off with this example right here. I'm going to be multiplying 8 to the 4th b squared times 2a b to the 10th. So 8 to the 4th is really just a. B squared is times b times b. This is times 2a, and then I got 10 b's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I combine these right here, what's 8 times 2? Shout it out.
16.
How many a's do I have?
8 of the 5.
1, 2, 3, 4, 5. A to the 5th.
B to the 12.
And b to the 1, 2, 3, 5, 6, 7, 8, 9, 12. So, if we're multiplying, what do you notice about the exponents here? B to the 2nd and b to the 12th? B to the 10th, we get b to the 12th. We add them, correct. Now, do I add 8 times 2? No. Multiplying the exponents, just add. But I'm just multiplying. So that's the shortcut there. So, pretty simple, yes? You vouch for one. Right here, 2a to the 4th, b squared over 18, a, b to the 8th, c. Oh, we're dividing. We're actually going to subtract, yeah. If you have trouble with that, though, you can also think of it like this. This is 2 times a to the 4th, and 2 b's here. Then 18, well, I'm actually going to make that, if you'll trust me here, 2 times 9, a, 1, 2, 3, 4, 5, 6, 7, 8, then c. And then I cancel out what I can. Oh, I got 2 on top and bottom. They're gone. I got a on bottom and a on top. They're gone. And they're gone. So what am I left with? A cubed on top. I got 9 on bottom. 1, 2, 3, 4, 5, 6. And then a c. And if we look at this, once again, we can subtract. So multiplying, we were adding the exponents. Dividing, we're going to subtract. Did I mess something up?
I just had a question. If
Yes.
you subtract, wouldn't it be negative b to the negative 6? Because 2 minus 8 is...
You are correct here, okay? It's 2 minus b to the 2 minus 8 is b to the negative 6th, right? But since we're doing it that way, it'd be on top. But b to the negative 6, negative means it goes from the top to the bottom. So b to the 6th, you can see how the b's are still on bottom there? Okay. Yes, we're subtracting. So this is a to the 4th, and this is a to the 1st. So 4 minus 1 is 3. There are more on top, so it's a to the 3rd. B squared of b to the 8th. 8 minus 2 is 6. But there are more b's on bottom, so it's b to the 6th on bottom. Pretty simple? Okay. And coming over here to this one. When in doubt, write it out. Okay? So, negative 3a to the 5th over b squared to the 3rd power. I am going to write it out. The 3rd power means multiply it by itself 3 times. Negative 3 a to the 5th over b squared times negative 3 a to the 5th over b squared times negative 3 a to the 5th over b squared. When in doubt, write it out. And now multiplying fractions is easy. What's negative 3 times negative 3 times negative 3? Negative 27. You added them, bud.
I did.
Negative 27. A to the 5th times a to the 5th times a to the 5th. a to the 15th. B squared times B squared times B squared.
B6.
B to the 6th. But we can also look at this the following way. 3 and 5 here. It's a to the 15th. What did I do there?
Multiply them.
If it's raised to a power, I multiply them. That's the shortcut. 5 times 3 is 15. 2 times 3 is 6. What exponent does the negative 3 have? It's got a 1. It's got an imaginary 1. So this is the same thing as saying negative 3 to the 3rd, a to the, well, 1 times 3, a to the 5 times 3, b to the 2 times 3. And 1 times 3 is 3. Negative 3 to the 3rd is negative 3 times negative 3 times negative 3. So when in doubt, write it out if you need to. Okay? But if mathematicians love finding the patterns and applying them. Okay? They love finding the patterns and applying them. So far, so good. Yes, ma'am.
Does that always work, the 5 times 3 and the 5 times 2, or is that just a special case?
Always.
Always, okay.
If it's raised to if whatever it is in parentheses and it's raised to an exponent, that always works. All right, a reminder, negative exponents. If I have 4x to negative 3 y squared, how would I get rid of the negative exponent here? Put what on the bottom? You're correct.
-3.
This is going to become 4 y squared. This goes down bottom. It switches from the top to the bottom. Oh, I remember. Yeah. This is a review of Algebra 1 stuff. So along the same lines here, what if I had 6x to negative 2, y to the 3rd, z, 4z to the negative 5. What would move around here? Give you about 15 seconds. Discuss it with your team. Go ahead.
No, you flip them. Put X on bottom and Z on top. Okay, change natives.
You want to join another group? You can.
Lose. Get back.
All right. What's going to switch? The x goes to the bottom because this has its own exponent of 1, right? So it's before. So the x is going to switch and the z is going to switch. So it's 6. We got 4 down here. So we got y cubed, that stays put. Then I've got z to the 5th. And then I've got x squared on bottom. Can I simplify anything else here? What? You're correct. What?
Is this 6 and 4?
Yeah! 3 and 2. Y cubed z to the 5th. And that's x squared. Next one, we got to find the degree. Find the degree of the polynomial. We'll start off with a simple one here. I know it's been probably about 1.5 years since you did this. Does anybody remember how to find the degree of the polynomial? No? It's the exponent, it's the highest exponent. So what's the highest exponent on this problem? 5! Highest exponent, not coefficient.
Got it.
Whoops. Yeah, that's 5. The degree of the highest exponent. Now, it changes up a little bit if you do the following. Like if I said 1/6 x squared y to the 5th minus 8x cubed. That one's actually not 5. Any guesses as to what it's going to be? The highest degree there. Just guesses?
The 3, because it has the highest number with x.
Highest number in front of the x, okay. Any other guesses?
It's gonna be 2.
It's going to be a 2, okay. Any other guesses? Says not the 5.
Oh.
He just
Okay.
Okay, this one's sneaky. It's actually going to be 7.
ooh.
The degree is 7. Why? Here there were no y terms to go with it. Okay, but here it's the degree is the sum of the. If you have multiple variables in there, it's the sum of the exponents. So if I had like x squared y to the 5th z to the 20th, it'd be to the degree would be the 27th.
Why wouldn't you add the 5 and the 3 instead of 2 and 5?
Just because you want to look at whichever term. Like this is one term, and this is another term.
Oh, okay.
That's one term, that's one term, that's one term, and that's one term. Okay.
So when it's all multiplying together, you can add
That's one
the
multiple.
exponents.
Yep. Well, you add the exponents to get the degree of it. Okay. The next one is actually a trick question. I'm telling you, it's a trick question. Why is it a trick question? Why is that a trick question? Because of the square root. The question is, find the degree of the polynomial. Guess what? That's not a polynomial. Okay? If I've got square roots, or if I've got like 1 over x's in there, like anything rational, it is not a polynomial. That's a polynomial, that's a polynomial, not a polynomial. All right, and the rest of the stuff here is pretty simple stuff that you've done already. Four x squared minus 9x plus 3 minus negative 2x squared plus 5x minus 6. What if I said 4x times 2x squared plus 3x minus 7? And squared plus 3x minus 4 times x minus 2. We're going to pause here and let you work these out with your team, and we'll just have each team take one. All right, the first one here, there's a little bit of confusion about this. There's a negative sign right here. So we can think of this as 4x squared minus 9x plus 3, okay, minus, well, I'm going to change that minus to a plus negative, and there's a 1 in front, plus negative 1 times 2x squared plus 5x minus 6. So I'm just going to distribute that negative. And so this is going to become negative 2x squared minus 5x, negative negative makes it plus 6. So I've got 4x squared minus 9x plus 3, and then I combine like terms. Well, that's a square and that's a square. So 4x squared minus 2x squared gives me 2x squareds. Negative 9x and negative 5x. Negative 5 minus negative 9 minus 5 is negative 14x. And then 3 plus 6 is 9. Remember, when we are adding or subtracting, do the exponents change?
No.
No, only when we're multiplying. Some people also might think of it this way. 4x squared minus negative 2x squared. I'm just subtracting, right? 4x squared minus negative 2x squared. Wait, was that negative in the original?
Yeah.
Oh, I suck.
Yeah.
I suck like a man with a milkshake. So that should be positive 2x, which makes that positive 6. Sorry. All right. So 4x squared minus negative 2x squared, well, that's going to give me 4 minus negative 2 gives me 6, right? Negative 9 minus 5 is negative 14. 3 minus negative 6. Some people look at it that way too. So that is our answer. All right, the next one. This is a monomial. It's got one term, mono. Monomials distribute to a trinomial, 3 terms. So 4x times 2x squared gives me 4 times 2 is 8, x cubed. Remember that's got an exponent of 1. 1 plus 2 is 3. 4x times 3x is 12x squared. 4x times negative 7 is negative 28x. Fantastic job. Whichever group did that. Was that you? You rock. Long distance high five. And the last one is the same sort of thing. We're just distributing. So x squared times x minus 2. So x squared times x is x cubed. Great. X squared times negative 2 is negative 2x squared. 3x times x is positive 3x squared. And then 3x times negative 2 is negative 6x. Doing great. Negative 4 times x, negative 4x. Negative 4 times negative 2 is positive 8. So then they just combine their like terms. Nothing to do with x cubed. So it stays by itself. Negative 2x squared plus 3x squared gives us just a positive 1x squared. Negative 6x minus 4x, negative 10x. And plus 8. And apparently, boom goes the dynamite.